All right, next up we have acids and bases. In this lab, we're going to be taking a look at the pH of different substances. To start things off, we're actually going to take a look at a series of solutions that are set to different pH values, ranging from 1 to, in this case, 13. These, you'll notice, have an interesting color to them. And that is because we've added something called a universal indicator. The universal indicator is essentially a way for us to tell the pH of something just based off of the color. Some of the colors will look a little bit similar. So we're going to have a still image for you to take a look at so that you can try and do a comparison of these different pH colors and then use them as a reference for later identification. Now that we've seen these different pH solutions and how they respond in color with the universal indicator, we're going to test a couple of solutions, some that we've seen in lab together. The 0.1 molar sodium chloride, 0.1 molar HCl, hydrochloric acid, the 0.1 molar sodium hydroxide, and then some household items like vinegar, dishwashing liquid, liquid detergent, and some good old antacid. Okay, we have our 7 solutions, again in order, the sodium chloride, HCl, and sodium hydroxide, and so on. We are going to add a little bit of the universal indicator to each of these solutions. A little dab will do you here. We just do a single drop in each of our test tubes. The universal indicator will change color in response to the pH of these solutions. And we can use that color to gauge the pH of these solutions. What you're going to do is use this color to, again, kind of guess what the pH of these solutions are by comparing them to the pH range that we saw earlier. We're going to mix these nice and thoroughly so you can get a better idea of the colors. Once we've used the colors to take a stab at what these pHs are, we're going to use something called a pH meter to verify whether these are acidic or basic solutions. So do your best to try and gauge what the pH of each of these solutions is based off of what color you see. Again, these are in order: the sodium chloride from left to right, sodium chloride, hydrochloric acid, sodium hydroxide, and then over here we have vinegar, dishwashing liquid, liquid detergent, and the antacid. Next, we're going to test the pH of each of these solutions using a little pH meter. Now these things have a little cap at the bottom. We remove the cap and we make sure that we rinse this in between each step with some DI water. So we'll move this around a little bit so that we have good contact with our probe and see what we get on the meter. Now it might be difficult to see on the screen, so we'll probably have to give you the pH values in post. Here we go. We're going to take a look at some buffers and compare them to water in terms of how they respond to the addition of acid or base. So this is something that we refer to as a buffer action. Now, in these 3 test tubes, I have just plain old tap water, buffer 1 and buffer 2. So what we're going to do first is add a little bit of universal indicator again. Again, you can use the color that comes from this universal indicator to gauge the approximate pH of these solutions. Again, we'll mix in our indicator well. And so, as you may have guessed, these are going to be buffers that are about 4 and 7. And we can also confirm this using our handy little pH meter. So with our pH meter, we have again, to get good contact, a pH of about 6. A little bit higher. A pH of about 4. Mix this to get good contact. So again, about 4. And then our second buffer solution should be similar to that of what we saw with our water, just based off of the color. And we see that we are back up to a little bit more than 7. It depends on the calibration of these pH meters. Mainly, we're just trying to see if we're getting consistent results. Now, the big thing here, again, is going to be the buffer action. What I'm going to do is add a small amount of acid to each of these solutions, and also a small amount of base to each of the solutions. And to show you the difference, I'm actually just going to do some controls here. So here I have just 2 more test tubes with just water. Again, this test tube, just water and a little bit of universal indicator. I'm going to add a bit more of the universal indicator to each one. So they should be the same color, because it is the same stuff in each of these test tubes. Now what we're going to do is add a small amount of hydrochloric acid. So we have a small amount of HCl. I'm going to add it to the middle test tube, just a single drop. And all it's going to take is that single drop to affect a pretty drastic change in the pH. Just based off of the color, we can tell that this is now a very different pH. In the third test tube on the far right, I'm going to add, again, just 1 drop, but this time of sodium hydroxide. So here we go, 1 single drop. And we see, again, a pretty drastic change. So this is what happens when we add just a single drop of either strong acid or strong base to pure water. Water doesn't seem to resist a change to that pH very well. We can also, again, test these pHs using our pH meter, which we'll show again in post. Now let's see what happens if we were to use our buffer. So here's buffer number 1 again. And again, I have 3 test tubes of the same solution. And again, I'm going to add a single drop of universal indicator to each one. And again, they're the same color because they're the same solution. And of course, it should be the same pH. Just like I did with the water, I'm now going to add a single drop of acid to our middle test tube. Single drop. And a single drop of sodium hydroxide to the far right test tube. So the sodium hydroxide has been added to the one on the far right. And again, I'm going to mix these a little bit. And we do see a little bit of a change, but it's not quite as drastic as what we saw with the water. So if we pan back to our water samples, right, think about the difference in pH that we saw here when we added just a single drop of acid or base, based off of the initial solution that we had. And then compare that to our buffer solution. This is our original buffer solution. This is adding a single drop of our acid, and this is a single drop of our base. Let's try this with our second buffer as well. If you recall, our second buffer was closer to a pH of 7, so it's a little bit more on the green side. Again, add our universal indicator. Mix things up nicely so that we get a consistent color all the way throughout the solution. And finally, add our acid to the middle test tube. And a drop of base to our third test tube. So we'll mix it up again. And again, we do see a little bit of a change, but again, that change isn't nearly as drastic as what we saw with our water solution. So this kind of shows us the effect of buffers on our systems. We may not be able to maintain the exact same pH, but we do maintain a roughly similar pH. Notice how everything still manages to be some kind of hue of green. And again, we'll actually test the pH using the pH meters and have those available for you to see later. And that is the effect of a buffer. It allows us to maintain relatively similar pH.